Hi everyone, welcome to my talk. My name is Lin and I am going to share you our recent studies in the direction of grasping habit. It has been suggested that our manual actions are controlled by two systems, the goal-direct system and the habitual system. Both systems contribute to action selection and mental planning. Previous studies found that individuals tend to hold a handled object habitually with their thumbs pointing towards the functional part, even when the functional part may not be used by the current task. This is the thumb toward bears. However, the neural basis of the habitual constraints in grasping selection is not fully understood. So in this study, we sought to investigate the neural mechanisms underlying grasping habit during the movement preparation. We recruited 22 right-hand participants to perform a grasp to rotate task with a rotation device here. Participants were instructed to grip the handle either habitually or non-habitually and then rotate the handle in 19 degrees according to the given cues. The experiment contains two blocks. Participants were asked to perform the movement task with one hand in the first block and then the other hand in the second block. Reaction time from the cue to movement, reach time from the button to handle, and the rotation time from the start position to the target position, and the EEG activities were recorded. We extracted the movement-related cortical potentials, the MRCPs, in a window 1100 millisecond before the movement onside to 300 millisecond after the movement onside. And the mean amplitude of the MRCPs were compared in 4 regions of interest: anterior, left, anterior right, posterior left, posterior right. And here we have the result. Behaviorally, we found the reaction time, reach time, and the rotation time were faster for the habitual than the non-habitual grasping in both left and right hand. For the MRCPs, we found the mean amplitude of the mean amplitude in the posterior areas was larger or more positive for the habitual than non-habitual grasping during the last 500 milliseconds before the movement onside. Such amplitude difference were only found in posterior areas, and no significant hand use effect were found for the MRCPs. In the follow-up correlation analysis, we found the mean amplitude of the posterior MRCPs were negatively correlated with the reaction time for right hand trials in both habitual and non-habitual conditions. However, no significant correlations were found for left-hand trials. Here is a summary of our result. Our results suggest that grasping habit does affect the preparation and execution of manual action. Instead of the anterior activities, grasping habit seems to be represented by the posterior movement-related activities during the movement preparation. For future studies, the interaction of hand use and grasping habit could be an interesting topic. Furthermore, future studies can also focus on the difference between the specified habitual non-habitual grasping as what we did in this study, and the free choice habitual and non-habitual grasping, which seems to be more natural as a movement we performed in everyday life. In the end, I would like to thank my co-authors, Professor Shark and Professor Koister, for their support in doing this study. If you have any question, you could reach me by my email here. We are happy to have some discussions with you. Thanks for your attention.